Item 13, landing and recovery. Touchdown and impact.
We practice getting rid of the parachutes in a hurry many times. When we hit, the power was warm. When we hit flat, it was a very soft landing. The sea state was didn't have much sea state. There weren't many waves, and the parachutes came down practically on a spacecraft, and I think the parachutes were jettisoned before they hit the water. Don't you?
Right. As soon as we touched down, we were spring loaded to go. The Gene would close the breakers and call, and then I would throw the switch. And right away, as soon as we splashed, and it was a very mild splash compared to what my Joning experience had been, and boom, right away the parachutes were there, and the shroud lines fell over on top of the spacecraft.
There was no tendency of the spacecraft to go one way or the other, and Tom immediately got out of the couch and went down the LEB, and that even made it more stable. Finally, all three of us got up and got out of the couch. And
the post-landing checklist was satisfactory. The temperature was mild, the humidity, there was no excess heat. Communications was excellent with the recovery, helicopters, and also with the Princeton. The swimmers plugged in the line, and it was overdriving a little bit, but we could read the swimmer real well, and everything went beautiful. There was no problem with respect to seasickness, lightheadedness. Everything was just beautiful. The recovery operation went very smooth, and we were picked up.
I dumped the dye marker in the water, and I saw it go right over the side. It didn't deploy, but at least it made it able for the swimmers to plug in.
We went through the power down checklist.
Yeah, including those switches those important switches on panel 250, which power down the whole vehicle, and we opened every circuit breaker we could get our hands on. Shut off every switch. Ventilation, we didn't use the post-landing ventilation system.
It was cool.
The hatch was open within a matter of 10 or 15
minutes. 10 minutes.
Yeah, as soon as the collar was on.
And
swimmers were in the water about the same time we were. Collar was put on, and it was estimated it was certainly not more than 30 minutes before the hatch was open, huh?
Oh no, it was open before 30 minutes. It was real fast, and we were out in the raft. The pickup was made 1, 2, 3 right in sequence.
It's all documented on TV anyway.
The couch position, the couch were left in a 180-degree position. There was no lightheadedness, dizziness, blurring, or dimming of vision.
No, at least I had no heavy foot. I felt fine. I felt as good as when I left the Cape.
Right. How are they going to get that on tape? Well, I want to talk about egressing. We crawled out of the vehicle into the life rafts with no problems. We had our life vests on, but did not deploy them. The crew was picked up in a basket nominally. There's nobody got dunked or anything this time. It was the operation was phenomenally professional. What else can you say? Item 14, Command Module Systems Operations.
Guidance and navigation.
ISS modes, ISS CDU. What is that?
The guidance and navigation system function, from my part of it, working with the computer.
Display of attitude errors.
Was just
lovely.
Beautiful.
4B takeover mode, we didn't use it. Thrust vector control mode. Beautiful. Temperature control, nominal. Optical subsystem, we've already discussed optical systems operations. Light transmittance. Let me say something about seeing stars with a limb on. I think you could see stars with a limb on if you pointed the whole stack plus x-axis to the sunshine. It looked like the one time that we inadvertently did that for a TV pass. I was down there looking through the optics, and I could make out constellations. I forget which constellations they were, but I could make them out, and I'd sort of recommend that as opposed to going to a planet option. If you want a quick realign in a hurry, just point the whole stack at the sun, which would be a very easy thing to do, and align the platform and go on from there. As soon as you got night adapted. Maybe you'd have to do it a little plus X down, I don't know. Okay, a sextant mechanical drive, beautiful. The sextant and the scanning telescope were beautiful. The light transmission of the telescope was pretty low, as has already been noted, but once you're night adapted, all the stars that you could see any other time were there. In fact, you're looking at too many of them in a lot of cases. Had difficulty picking out the right stars. And of course, in the daytime you couldn't see any stars, but you could see the planets in the Earth-Moon-Sun combination. Smoothless. The sextant is so much more smoother than the simulator. It's not even worth considering. Stability, beautiful. Zero optics mode worked great. Manual mode's great. Computer modes, okay. Optics drives. Subsystems, instructions and programs. Recommendations already been made to modify landmark tracking programs and P23 programs. The one to allow you to do auto optics calibration of the star, and the other one to display 1691 while you're in a landmark tracking option, and to drive the optics in trunnion out to the 50-degree mark prior to making the 50-degree angle track mark to save you 10 to 15 seconds. The R2 model takes a long time to run. Verb 83s takes a long time to run. It was noticed that the processing of optics and VHF marks was much faster than it was in a simulator, and where in a simulator you could only take 2 optics marks a minute, in a spacecraft you could take 3 to 4 optics marks a minute. Flag bit check, we didn't do any of that. We had number of program alarms due primarily to taking marks when flashing 51 wouldn't call for in P23, sometimes in P52, and also program alarms associated with Verb 41, now 91, and those are all the program alarms I remember. But in every case that we had a program alarm, it was obvious for what the reason the program alarm was for. Sometimes the auto optics did not track when the optics power switch had been off, but that was because I forgot to zero the optics to set the zero flag and all those things. There was not a single program alarm, except for one. We had a 113 program alarm, which indicated an inadvertent mark button, and I don't remember ever doing that, but maybe we did. But all the rest of the program alarms were well understood, and really were no cause for concern. They just remind you to do the right thing. We didn't perform the CMC, the computer self-check doing reentry, and I question the reason for ever having to do this. The people at the Cape told me that the computer self-check does not really self-check the computer, so I think I recommend it should be deleted from the checklist.
Boy, I second that. When the computer has functioned nominally, you've got faith in it, you've seen its reactions, you've seen its computations and integration. I don't think you want to mess with the self-test.
The input-output channels, everything worked. Displaying a keyboard, use and number of errors. We didn't have any gimbal locks. I guess it's the first flight we
First
didn't get
flight.
the gimbal lock.
We came close on one vehicle, but.
Yeah, and manual computer restarts. We had none of those. We had no restarts. In short, the GNN computer and ISS worked beautifully. Controls and displays, the entry monitor system. The entry monitor system worked great. You couldn't set it on 0 and go to the EMS, the Delta V counter. You could not set that on 0 and go without getting a jump. Now you could sometimes, but every other time or so it would jump to 10 or 25 feet. It didn't seem to make any difference to it. The Delta V check worked on every case as long as we were in what the heck was that, Delta V and normal when we set it up, right? When we set it up in Delta V and standby, it didn't work. Remember that? FDIs, great. Gimbal position and fuel pressure indicators, great. Attitude set control panel, great. Hand controllers, okay. GNC switching interface, I don't know what the hell that is. GNN power switch, we didn't turn it off. Disky operation in verb noun formats, okay. Control programs and routines, okay. CMC, SPS, TVC, great. Stabilization control system, control. Adequate. Recommendations have been made about modifying the CMS to reflect the actual control dynamics of the command module. Doing SPS burns. The rest of the control dynamics appear to be just like the CMS. All rates nominal, all operations nominal. What do you think? Right? What can we say? Min impulse, just like downtown. Thrust vector control, Delta V, okay, orbit and deorbit thrusting, nominal, loop control functions, FDIs, disky switch locations, okay, shoot, we ain't gonna change those now. Service propulsion system, good. Thrust vector alignment, no sweat. Oh, it was noted that the engine thrust vector alignment, the CMC would put the GPIs at a different place than they indicated on the gauge, but we allowed for that by trimming them to the same position with the thumb wheels on the GPIs that the CMC would have put them. So we felt we had a pretty good hack on the trim for if we had to do a takeover. And it was like on the order of 0.2 of a degree, no sweat, what the heck. Awareness of gimbal movement. Yeah.
Not during burns, but during the gimbal drive test. Were you aware of it during burns?
Yeah.
Oh, well, you could
I
see
was watching it.
Oh, you were
You could
watching.
see the rates going.
I was watching it. Of course, I had the rates on 5 and 1 for SPS burns, so I was watching all that good stuff. Direct thrust on switch, didn't use. Direct voltage button, we didn't use. Thrust on button, we didn't use, but we were ready to. PC indicator worked just like downtown. The PC indicator, when it was reading 0, indicated 5. And when it indicated, it started out indicating a low value for chamber pressure, but as the mission went on, it indicated 102, 103 psi for the LOI and TEI burns, which is where it counted with both banks. Pugs, you want to say something about the pugs?
Yeah, the pugs, let me go through the whole story on the pugs. The pugs was, when we lifted off, the pug was reading 50 on a decrease side, which was still in the green band. After our first burn, we had our first burns were short, so we didn't even do anything to the pugs because you really want to wait till about 15 seconds until things stabilize, settle down. But for LOI, our first big burn, the pugs was, it was watching after 15 seconds, the decrease indicator, oxidizer increase decrease indicator went from 50 decrease to about 150 decrease. At that time I went to the decrease position on the switch. The decrease indicator then slowed down to a point about 200, started reversing itself, and when it got just about to 0, the Pugs valve, oxidizer valve, was neutralized, put in a normal position. Then, as the burn continued, the increase-decrease indicator then started to go to the increase side, and at the completion of the burn, I believe was somewhere, well, it started to go to the increase side, and when it got to about 100, the switch was thrown to the increase, but the increase or the unbalance continued. At the completion of the burn, it was somewhere between 300 and 400. This is documented on tape, but somewhere between 300 and 400 on the increase side. Subsequently, on SPS burns, let me backtrack. Just before the completion of the LOI burn, to put everything in a nominal condition for shutdown, I went to the normal position on the oxidizer flow control valve. This made the increase, the unbalance, go even further to somewhere close to 400 on the increase side. Subsequent burn, it was recommended that we go ahead and put the switch to the increased position again, knowing full well that it appeared that the oxidizer flow valve was not handling the imbalance properly, but to go to the increased position after we got the second bank of ball valves in, so we would not start with a transient. So after the second bank of ball valves was put in, the switch went to the increased position, and during the TEI burn, the unbalance continued beyond 400 to off-scale high and remained there throughout the burn. We ended up with somewhere with about 9% of oxidizer and about 6% of fuel when we shut down the TEI burn, and it was apparent to me that the Pugs was not functioning properly after the very first burn. The numbers have been documented and are available, the exact unbalanced numbers.
Reaction control system, just like
As per specification.
as per specification. We primarily operate a reaction control system in
Auto and pulse.
auto, CMC and auto and pulse mode.
Okay.
Sometime we went to acceleration command when we had a whole stack on there, and used, but we found very easy to control roll and
Pulse.
pulse.
We used the acceleration command mode to decrease the fuel usage to achieve certain rates over a series of pulse, because the ISP is better. And it looked like our total fuel usage worked out great, just like we planned.
Awareness. With the helmets and gloves on, you could not hear the jets, the initial thunk of the solenoids, and you could not hear with helmets and gloves off. It didn't appear to me that you could hear continuous thrusting, but you could always hear the initial clunk when either the solenoids engage or there's a hot explosion when these things fired, and it was a valuable cue as to whether or not you got any output out of the machinery. Right. I think we ought to modify the CMS so it doesn't reflect this continual shh, and just give it that one clunk and let it go at that.
Right.
Command module RCS. Command module RCS, you could hear those fire continuously, and the pressure switch worked. You could hear the little clunk as it fired. You could hear the gurgle as the propellants went down to the various places that all they went. And the CSM SEP switch, it works. What are you going to say? It makes a big noise. You hear a pretty good sharp crack as a cue that things are going on back there. Isolation switches, direct RCS, you could hear those thrusters firing. They're not as loud as we have them turned up in the command module right now.
You can hear the transfer between service module and command module also.
Yeah.
Very, very audibly detectable.
Yeah. I couldn't hear the SPS fire either. I never heard that thing.
No.
We
But
never
you
heard
sure
any big
feel it.
engine fire.
You sure know it's
The
going.
acceleration is
There's no doubt in your
instantaneous.
mind, babe.
Acceleration has been
It's not as
described.
bad as that Agena was though, man. Man, that Agena really won't be all of a sudden like. Maybe that's because we're sitting backwards.
He had eyeballs out
Yeah.
acceleration.
Okay, 14.5, the electrical power system, the fuel cells. We never had any abnormal talkbacks, any pH indicators. We did have a fuel cell anomaly. Fuel cell 1 on the third day in lunar orbit, sometime after probably 108 to 112 hours. The circuit breaker on a fuel cell number 1 pump package popped. We did not catch it because there were no anomalies on our gauges at that time. All the temperatures were still in limits. It was caught by the ground. We went down there to reset this breaker. We tried resetting it. As soon as we did, it popped out immediately, gave us a main bus undervolt light and an AC bus 1 light.
I felt that breaker and it was warm.
The breaker was warm.
Yeah.
So we immediately made a decision not to try and reset it. This meant that we lost the pump cooling package capability on fuel cell 1, not necessarily the whole fuel cell. So we ran it for a while until the skin temperature got up to the mid-nominal range of operation, and decided that continued operation would just increase it without cooling. So we took it off the line, and from then on, we operated somewhere between 26 and 27.5 volts, depending upon the load on the spacecraft. There was only one time when some cryotank heaters cycled that we got a undervolt light on the main buses, and after that period of time, we were very careful as to what we had powered up and what we did not have powered up, and we turned things like potable water heater off and optics power off, and a number of other things that were not necessary, S-band antenna power when we didn't need them. Turn these things off just to keep our main bus voltage above 27. For the most part, it stayed at 27 or 27.5 volts on 2 fuel cells. So we had the capability of fuel cell 1 if we needed it after it cooled down, or with a continuous purge. And a continuous purge, hydrogen purge, was limited by the duration of the mission yet to go and by the amount of hydrogen. So the further on we got into the mission, the better off we were for using that fuel cell. We did bring that particular fuel cell on for a couple major events, one of them being the TEI burn, at which time it had cooled down. Condenser exhaust temperature had cooled, skin temperature had cooled down rather below the nominal. When we brought the fuel cell on an hour and a half before the burn, it had by burn time it had picked up its 30% of the load or 33% of the load and performed nominally, and we had it on the line for a total of about 4 hours.
You said about the O2 flow in?
Okay, we lifted off, however, with the O2 flow indicator on. That same fuel cell failed. We knew it was failed, off scale low, so we had no indication of oxygen flow in that fuel cell. So effectively, from that point on, we operated with 2 fuel cells. We had one other fuel cell anomaly on fuel cell 2, and this anomaly occurred about 10 to 12 hours before TEI, at the same time that we had fuel cell number 1 off the line and the fuel cell number 1 light on. The condenser exhaust temperature on fuel cell 2 slowly started oscillating between the upper and lower limits of the caution and warning temperature parameters. And it oscillated at about 2 cycles per minute. And about every 10th cycle, it got low enough where it triggered the caution and warning master alarm at the lower limit. The first time we saw this, and the first time we were alerted to it, was just as we went behind the moon at about 10 to 12 hours before TEI, when fuel cell number 2 and a master alarm light came on to keep the fuel cell number 1 light company. So we saw this condition, and of course we monitored and watched it pretty closely. The fuel cell output was holding up, the voltage was holding up, but the temperature on the condenser exhaust was cycling. When we came back into sunlight, and we're in sunlight for about 10 minutes, and we were doing landmark tracking for the most part over this particular day, the cycle slowed down and eventually damped out at the nominal temperature. And then when we went into darkness, and we're in the darkness for about 10 minutes, the cycle slowly started up and it peaked out at probably somewhere between the early third of darkness and continued on through darkness, triggering a master alarm occasionally. And this continued on right up and through and into TEI. After TEI, when we went into the PTC mode of operation on the coast back to the Earth, the condenser exhaust temperature remained stabilized at the nominal temperature, and we'd never seen this condition again. The thing that bothered us was we had one fuel cell off the line because of a condenser exhaust pump problem, temperature and pump package problem, and now we're apparently having possibly a similar problem. However, not known to us at that time, and I think it should have been known, was the fact that this same cycle occurred on one of the fuel cells on Apollo 8 when they were in lunar orbit. So apparently there's some thermal condition that certain fuel cells are sensitive to in the lunar orbit day-night cycle. But we continued home on 2 fuel cells. We brought fuel cell number 1 up once, maybe twice, but it really wasn't needed, and we didn't have to really power down. The trans-Earth coast was nominal, and the fuel cell voltage remained between 27, 27.5, 28 volts all the way home.
The only items that we powered down was to turn off the optics power switch, the GDC, and the potable water heater.
Now we ran in a configuration
And a radar transponder.
Radar.
Now we ran in a configuration with 2 fuel cells, a fuel cell number 2 on main bus A, fuel cell number 3 on main bus B, and the buses were not interconnected. When we brought up fuel cell number 1, we interconnected it between both main buses, and this configuration worked very fine.
I guess this is a pet peeve of mine, but this is kind of dangerous. That IMU power switch down in the LED, being right next to the
Should have
optics
a
power
guard on it.
switch,
Should have a guard.
ought to have a guard over it to prevent inadvertent switching. That whole LED area is real dark. What you end up doing, if you got any brains, is you turn up all the lights in there and you look at that bastard very carefully before you turn it off. You can take the guard off the S4B IMU CMC switch and put it down there where it belongs, and take it off there where it don't belong and shouldn't be. One of these days, if you ever had to do an S4B takeover or a Saturn V takeover, and you have to raise a cotton picking guard to get the switch to do it, you just bought yourself the 2 seconds that prevents you from making it and not making it.
It's our recommendation that sometime prior to flight, you might want to leave it on there so a technician will not bump into it.
Yeah.
But prior to flight, it's a 5-minute job that the S4B IMU switch guard be removed just prior to flight.
We end up flying with the thing raised, the guard raised. Now, see, that prevents a spacecraft modification, but
Well, we flew with it raised in case we had to throw the switch. See, particularly in the max Curie when you'd switch over to the polynomial, and or if you had a guidance diversion where you had to be on it real fast. And so we flew with the switch raised. The lighting, as John described down in the lower equipment bay, that does make you think and look very close before you ever throw any switch there, because the optic switch is next to the IMU power switch.
and you ought to power down your optics just to keep them from being heated and running all the time, but you damn sure don't want to turn off the IMU inadvertently.
We had nominal batteries. Battery C held just about 37 volts without a charge. The whole mission was never used until reentry. We continually charged alternately battery A and battery B. They accepted the charge real well over 4, 6, and 8 hour periods. However, we never really saw 39.5 volts, which is a criteria to terminate the charge. We got down as low as maybe a half an amp, but more like about 3/4 of an amp, and we charged the batteries really on a basis of time, or whether we'd gone into a sleep period, and on a recommendation of the ground, we terminated the periodic charges. All the DC monitor groups, AC monitor groups, all work very well. It was very evident, just like the simulator, that you can tell exactly when the gimbal motors are coming on, and a positive indication through the H2 and O2 flow indications on the fuel cells and through the amperage, the current position on the or the ammeter position on the monitor group. You can see those gimbals not only come on, but you can see them move. The inverters work beautifully. We never had to go to the third inverter. Main bus ties work beautifully. You can of course monitor through your DC voltmeter whether you really had the battery buses tied to the main buses, and that was done every time we turned the main bus ties on, and we got a verification of that before we started the gimbal motors. Non-essential bus switch, no problems, not even used. G&M power switch was just left alone. Cryogenics system worked real fine. It appeared to me that the O2 heaters, auto heaters, kept the O2 tank pressures down around the bottom of the nominally green area. We never saw, very seldom saw, medium to high pressures in the O2 tanks. They were always on the bottom side, but never got any caution and warning lights on those two particular tanks. We did get a cryo caution warning light about 2 or 3 times on low hydrogen pressure, either in tank 1 or tank 2. The heater cycles were effectively set up prior to sleep periods on ground recommendations as to whether they be auto or off, or whether we had to go on with them. It appeared that towards the end of the mission, on the 7th day, that one of our hydrogen auto heaters stuck in the on position because of the continued temperature increase, and we just played that from the off to the on position without any trouble, and it was on the 7th day of the flight. The fan switches worked real fine. The cryos were circulated prior to sleep periods and prior to burns, and when we were in the 2 fuel cell condition around the moon, where we certainly wanted to conserve our power and our low voltage capability, instead of using the heaters for cryo pressures, we used the fans, which we were told required a lot less power to operate, and it was evident on our voltmeter that when we cycled a fan instead of a heater, that instead of getting a half a volt drop, we barely could even see the fan come on, or the fan come on. I think that pretty much concludes the EPS system, and the 2 main concerns we have certainly are those 2 fuel cells. I think possibly the failures or the anomalies are of different nature, although they resulted in roughly the same condition, or the second one, if it had, the second fuel cell, if it had actually failed in a pump package area, would have resulted in the same condition as we had on the first one.
Yeah. Okay. Environmental control system. Environmental control system worked normally throughout the mission. We used the repress package, and it's not a rapid repress package, for things like LEM repress after we pulled it out of the, before we pulled it out of the S4B, and LEM repress after we got into lunar orbit before we went over to it the first time, and checking our hatch seal when we couldn't vent the tunnel. The major discrepancy we had in the environmental control system was the clogging of the LEM tunnel vent system. We couldn't vent the LEM tunnel vent. The regulator valves worked okay. Emergency cabin regulator worked okay. The cabin atmosphere in general was noted to be very comfortable. The humidity collecting in sufficient amounts to probably cause problems were noted during 2 SPS burns, TEI and LOI.
When water collected
on the floor. We had, after we got rid of the lunar module, we had water condense out on the hatch, and then it was noted that up near the hatch seal ring that water turned to ice. It was 20 degrees cooler in the tunnel on the return trip, at least 20 degrees cooler. It is recommended that part of the pre-sleep and post-sleep checklists include wiping down the tunnel hatch doing trans-earth coast, and that prior to any burns the tunnel hatch be wiped down, and prior to re-entry that the tunnel hatch be wiped down to prevent accumulation of water on the center seat crewman. CO2 removal, circulation. Floating particles, there were numerous floating particles. The inflow valve had to be repeatedly cleaned due to the fiberglass insulation floating around the cockpit. The inflow valve, and also the little screens that we put over the exhaust hoses. The intake hoses on the environmental control system hoses had to be cleaned. Odors, the odor scrubbing of the cabin was, what do you say, satisfactory?
Satisfactory.
Well, it was noticed in the first part of the mission that toward the end of canister operation, I seemed to notice more objectionable odor, and then we changed our canister and it cleared right up. But I didn't notice it during the last part of the mission. Inducement to cough. There was some coughing involved because of the fiberglass. It was irritating to the skin, and some eye irritation, particularly to the LMP and the CDR were produced. Well, there was no the cabin circulation was adequate. The hoses, when we were unsuited, the hoses were placed around the spacecraft, and on the trans-Earth coast they were taped together, pointing in opposite directions, so the exhaust hose was pointing in one direction and the intake hose was pointing in another direction, and it provided adequate circulation and kept the cabin well scrubbed. Cabin fans were not used, and it served no useful purpose on that mission. Water supply tank. The potable tank that serviced that gate was full of bubbly water. After the potable tank inlet valve was open, the water was still bubbly. The chlorine injection was nominal in every respect. In one case,
Except the first direction, we questioned about putting chlorine in. The tank did not have the valve open. We were directed upon the advice of the medical group to inject another ampule of chlorine.
yeah, and by putting in another ampule of chlorine, and we were told to keep the potable tank inlet valve closed, and as a result we ended up with a line full of chlorine, which made it very objectionable to drink and caused a great deal of discomfort to the crewmen who ended up drinking it. Food preparation
You want to talk about
was a
one
complete
more
fiasco.
anomaly on the water system is that the seventh, towards the end of the seventh day, the water gun apparently put out drinking water at a extremely reduced pressure for a period of a couple hours, and then after more water was taken out of the system, the pressure came back up to normal.
I remember that. Yeah. No explanation for that.
There was no kinks in the hoses or anything. It was all investigated. The valve was on. It just was reduced pressure water, and then after more water was taken out, it returned to normal.
The water, what else can you say about it? No, food
Nothing.
preparation was normal. The water glycol system,
You
Well,
can go
something
through all
about
these
that.
items, but the whole water glycol system performed as it was built to perform. The pressures were nominal, the temperatures were nominal,
okay, let's do it that way.
the radiators were nominal, everything performed just as expected.
Okay, the same can be said of the suit circuit. The ECS gauging system.
Why don't you mention the O2 flow high rate when you,
Okay, well, there were several cases where O2 flow highlights occurred due to several reasons. The main one of which was that I was either in a suit with the inflow valve closed, or the fiberglass insulation had clogged up the inflow valve, and they resulted in O2 flow high. But both the reasons for these O2 flow highlights were very apparent, and the decision was made to press on and ignore them. In every case where we found out what the problem was, things returned to normal. We had an O2 flow highlight when we first started the mission, remember that? For a long period of time. And I think it was due to the fact that we're recharging the repress package in the ECS package, but seemed like it just sort of went away.
I
over a
remember it,
period
and
of
I don't
time.
remember why. It
And
seemed
we-
like it was explainable at that time. But
When we closed the vent valve at 8 hours, we never did see it after that much. The gauging system was nominal, the waste management system, the fecal disposal system, the roll-on cuffs, the fecal disposal system and the waste and the roll-on cuffs, and it's a complete mess. But what can you say about it? It operates just the way we thought it would operate. I don't know how you're going to make it operate any better.
it's a poor last, but there's nothing in front of it.
That's right.
Telecommunications was all nominal. Individual audio center controls operated. The VHF was poor compared to the S-band, and we really operated on S-band effectively for the whole mission.
There's unexplained anomaly about the operation of VHF when we were working with a limb, but
It might have been antenna patterns, it might have been corona. It's hard to say what it was when we were operating with the LEM on VHF B duplex. But other than that, the VHF performed nominally. Apparently the recovery beacon was heard, or was tracked. Operation of the S-band high gain antenna, the antenna operated very well, including in a react mode, which we use quite a bit, going to and from and in lunar orbit. Beam width switch, actually you could acquire very readily in the medium beam width position, and then go to and you get auto lock, and then to peak up the signal strength a tad, you could go to narrow, but actually you could even operate on beam width on middle beam width, medium beam width for most of the time if we really had to, but we just went to narrow and peaked up the signal, and the auto track held it. Could not hear or feel or see the S-band antenna bang around. We used a CMC diskey to obtain antenna pointing angles much of the time, and they worked out perfectly. We got the rest of the angles from the ground when we maneuvered to particular positions to get TV track or burn attitudes or what have you. S-band TV apparently worked excellently. The DSV tape apparently did not fail and worked throughout the flight. No comments on arranging. Oscillator, power amplifier.
what can you say? All that stuff.
Everything worked. Everything we needed worked as prescribed.
Okay, what are going down through 7?
Voice 7, a tape recorder, power switches, everything worked right. The voice recorder indicator worked right, to the best of our knowledge, because we saw it gray a good period of time, especially on the back side of the moon. This switching, tape recorder switching, for the most part was done by the ground. Omni antenna switching or omni / high gain switching was done for the most part via the ground. PCT switches worked.
Let me say something about when you guys were in the LAM. I operated with a VHF squelch all the way off, with no squelch, and we had ranges out to about 300 miles, except when you were pointed in the other way. And I'm sure that was an antenna pattern problem.
That was probably an antenna pattern problem from the LEM, because I really didn't do much at VHF antenna switching.
Yeah.
The box circuitry was used.
Mr. Holloway is on.
Box was used very limitedly, but when it was used during some of the TV commentary for ease and PTT operation, it worked.
Yeah. Okay.
That takes us through nothing you can say for the comm except it worked as prescribed.
That S-band comm is the greatest thing going. It sounds like you're sitting right there on the ground with somebody.
The only
around the
problem
moon.
at lunar distances that we ran into is the time delay between the Capcom and the spacecraft. You tend to cut each other out and interrupt each other.
All right, and from that, we ought to adhere to the discipline that when you end every transmission, you say over.
Right. Okay, and we ran the entire mission once we found out things were all right with the S-band squelch enabled. You still know when you lose comm, you hear the crackling in your earphones, and it's quite evident when you go around the hill around the moon, you get a and it's gone. And I see no reason for ever having that switch in any other but enable position. It keeps all the noise out of your earphones, and it doesn't degrade comm in any manner that we can see. Mechanical operation of the tunnel. The tunnel operated the drogue, the probe, the lighting, operated normally with exceptions as previously noted. Latches 3, 4, and 10 were one-shot cock latches. Latch number 1 you had to use the auxiliary override to cock it, and there were no the probe and drogue operated as per checklists.
Takes us to the lunar module systems operation. Into the GNN. The IMU was powered up, was aligned in the dock configuration, performed as expected. We saw very little drift between it and the AGS for 30, 40, 60 minutes after AGS updates. TP, you got anything you want to?
No, the only on the pings there was no anomalies there at all.
We saw differences in time delays on Verb 82s and Verb 83s particularly. At sometimes Verb 83 would take forever to come up, like 3 minutes and maybe even 4 minutes.
At time, one of them was, sometimes it would come up in 35 seconds of minimum time, other times it was in excess of 4 minutes.
And at times when it was too long and we needed the computer back more than we needed the Verb 83 information, we put in a Verb 96, stopped integration, and then proceeded on with the use of the computer, which worked perfectly fine.
This was also noted in the command module.
That's right.
The same thing in the command module, and
Must
it
be a
appeared
function
that
of
Verb
RPM.
83 required longer than Verb 82. Verb 82 had some
Yeah.
delays, but Verb 83, and when it delayed, it was definitely longer than Verb 82.
Okay, on the optical subsystem, although it worked nominally and we got good alignments out of it, there's a few small things that need to be mentioned. The AOT, within the reticle area of the AOT, they were 3 or 4 hairs, literally hairs. They were not cracks of any sort. They looked like hairs that were within the field of view. They were not close enough to the center to make any difference or bother any of the alignments. The center of the AOT, particularly in the plus Y direction, there was an area of that transmitted probably about 30 or 40% of the light that the rest of the AOT transmitted, which made it very difficult to align and mark on stars close to the center of the reticle. The star brightness would dim very slowly, and then there were certain positions right within about a radius of about 5 or 6 star diameters around the center of the crosshairs, at which a star would actually disappear entirely. And this was a little bit aggravating because this was a problem we had in the simulator, which was not supposedly a problem in the spacecraft. On the minus Y and on the bottom side of the reticle, this was not so pronounced, but however it was throughout a omnidirectional area right around the center of the crosshairs. The dimmer control. Electrically worked okay, but mechanically you could dim it from no reticle at all to a very, very dim condition, and then the rheostat, the thumb wheel, would literally, physically I should say, fall or rotate forward as if it were on, there was an over-center spring, and would go to a very bright position, and then it went from very bright to extremely bright. So you almost had to either accept it in a dim position to mark on stars, a very dim position, or physically hold it with your hand in that mechanical dynamic area where it wouldn't want to stay. And the latter was very difficult when you needed that particular hand and those fingers to actually do the marking. Field of view was adequate. I mentioned the light transmittance in that central area. Other than that, it was very good. No other problems. The interface with the computer was excellent. The alignments came out very good based upon our third star checks. Put the star right smack in the center of the reticle within the limits of the DAP deadbands we had in. And I guess that brings us to rendezvous radar.
And the rendezvous radar test that we performed was nominal, just as prescribed. The radar worked exactly as prescribed, and in the simulator we could track the side lobe patterns, and we never had difficulty locking onto a side lobe. We locked on out at the max range and had it for a period of time, and however the command module maneuvered to an attitude for a backup burn, and due to its transponder pattern we slowly lost lock. So but the total correlation between voltage of AGC versus range was as the pre-flight data was predicted, and very helpful. Under landing radar, again, the landing radar self-test went exactly as prescribed. The landing radar was turned on earlier than prescribed in the flight plan. The attitude approach for local horizontal plus 10 degrees, and as soon as we went to the attitude, we had an indication right away that the landing radar had locked on to the surface. Computer.
The first thing. Okay, the computer, the LGC. The LGC self-test was done pre-separation. It passed with flying colors. Everything was nominal, just as the checklist predicted. The LGC worked excellent in every program, every pre-thrust, thrust program we used it. All the alignment programs worked well. We had no unexplainable master alarms that I can recall at all. The control of the vehicle was as prescribed. All of our updates required that we go into ground updates required that we go into up data link and then go into POO, which we did every time, which kept all the flag words set, and we had no problem with up data links through the S-band. We had no restarts, and I can't say more than that. The computer worked exactly as we had hoped it would. GNN control and displays. Steve, why don't you hit that?
The FDAI worked as prescribed. The only display which was not, and this was not a GNN, this was a rate gyro displaying the calibration of the FDAI, which part of it comes on the rate gyros, which is not associated with the GNN. Not being completely zeroed has been discussed before, but the GNN, all the displays were good.
Procedural data, we found out that the DSKY works very fine with the commander's right arm and the LMP's left arm. And that's the way we used it, passed it back and forth to each other, and no problems in its coordination. And I guess that takes us to the AGS. AGS alignments. AGS alignments were made numerously throughout the flight, and more predictedly the way they were called for in the LEM rendezvous flight plan Updating of the ags occurred just as we had planned it, and there was only one time where the ags was attempted to be initialized with the high bit rate switch and high, and lo and behold it didn't initialize, but every other time it state vector was initialized properly. There's only one anomaly in the update alignment sequence, and that was prior to undocking. When the ags was aligned to the pings, verb 83 was checked against range, rate, and theta, and theta was found to be in disagreement between the pings and the ags by as much as 30 degrees. The sequence of update and alignment was made 3 separate times prior to undocking, and the 30-degree bias between the two in theta was seen every time. After we separated, address 304 of the ags was looked at again, and I don't really recall whether this was before the next update after separation or after it, but from then on the verb 83 theta, range and range rate, and the ags range, rate, and theta all agreed very, very closely. The ags calibration was started. The initial numbers were recorded, but due to the roll thruster limitations of the command module, because of the pressurized tunnel, we were not able to hold the proper angles and minimum deadbands required to do the ags calibration, so no accelerometer or gyro calibration was completed. The rendezvous radar navigation, there were no radar updates put into the LEM for CSI and CDH because of the radar filter problem. There was no radar inputs put into the ags for TPI because of the time element involved. This is all pre-planned. There's no deviation from the pre-flight checklist, pre-flight rendezvous procedures. However, the ags computations of TPI based upon the state vector obtained from the LGC was within 0.2 of a foot per second agreement in total velocity required, and within 10 to 20 seconds agreement on the in time as for execution of TPI based upon the same theta of 26.6 degrees. From the standpoint of the ags time held the whole time, it never varied. Address 407, which freezes a reference frame, which in Earth orbit on LEM 3 continued to be recycled to 10,000 through small accelerations, was monitored prior to every burn. It stayed at 0 as expected in lunar orbit. The keyboard, the displays worked better than the simulator as far as being able to push buttons easily and get your readouts. Power up was nominal, and as far as I'm concerned, the ags monitored every burn, and I really believe that every big engine burn could have been done on the ags with residuals nominal enough to complete a very nominal rendezvous. The
The ags as a control system performed as per specification. When the descent stage was attached, for certain attitude maneuvers I would use ags and pulse. However, once staging occurred, I only used pings and pulse. Ags and pulse had too much authority for the lightweight vehicle. The ags attitude hold mode performed satisfactorily for both the staged and unstaged vehicle. We did use ags, now this is from the computer function for radar acquisition, and that worked out very good.
Yeah, address 400 plus 20,000 for target acquisition and 400 plus 10,000 for burn attitudes agreed very closely with the pings and were used, particularly the target acquisition, were used for manual acquisition of the target while the pings was being reprogrammed, or not reprogrammed, but recalled for P20.
The staging anomaly in which a parallax in viewing the switch position has been previously described. When I switched to the mode, was an AGS, but in pulse, and I switched to the mode control position, the vehicle started light dynamics. After staging was initiated, then with the light vehicle, it started off. At that time, I rechecked a series of switch positions real fast, and then it went to direct and to damp the rates and start to maneuver around to the insertion attitude. The AGS attitude hold mode was used for the CDH burn to accomplish a detailed test objective, and it was a very tight control mode and performed satisfactorily. Propulsion system. The descent engine burn was made in a satisfactory manner. The first burn DOI was the ullage came on as initiated by the pings. The engine throttled right up. However, the thrust chamber pressure appeared to be more than 10%. I'd estimate approximately 15%. Then I throttled up rapidly to 40% for the profile of DOI, and there was no rough combustion or chugging in the engine at all. The shutdown occurred right on time, and the residuals were residuals were noted in the flight plan data. During the guidance during the DOI burn was absolutely nominal with no deviations at all.
The engine could not be seen, nor could it be heard. The only feel of
was a feeling of acceleration.
The feel of acceleration and watching the computers count.
During the phasing burn, the ullage was started again by the computer. The engine ignited to exactly 10% and continued on this. And a few seconds after ignition, the descent propellant quantity light came on, followed by the master warning light, master caution light simultaneously. This was immediately pushed out, and the burn was guided very straight. This was followed by the Deca gimbal light coming on. I rechecked real rapidly the attitude arrows, needles, and the rates. The rates were 0 for all purposes, and no attitude arrow deviations, and so the engine gimbal enable switch was not placed off, as had been previously briefed as a procedure.
The descent quantity light apparently went out then, and then came on again.
After the computer throttled the engine up to 100%, after 26 seconds of thrust, the descent propellant quantity light came on again with an accompanied master caution light, which is pushed. Then the engine shut down, and the residuals were very nominal, as outlined. Under the ascent engine. The ascent engine insertion burn was made with the pings. The ullage was started by the computer. At ignition, the engine right away, instantaneously came to thrust, and the acceleration was very obvious. And during the burn, you could hear thrusters firing, and the engine had both a yaw and pitch. The vehicle had a yaw and pitch oscillations that we had expected from reviewing the data from the LIM 3 ascent burn to depletion. Again, it was a different type of operation than we'd experienced before in any of our burns, and however we anticipated that this would occur, and we had the restraint harness locked, and the type of oscillation was similar to a Dutch roll in an aircraft. And I'd estimate that we would occasionally reach up to 5 degrees per second in pitch and yawing rates.
It was a definite, discernible wallow.
It was a wallow, and we could see the attitude arrow needles varying. At the shutdown, though, the guidance was perfect and the residuals were nominal.
Does a simulator do like that?
No.
No?
At least what we'd seen on the simulator was just a straight, and there was no attitude arrow needle variation like we'd experienced in the burn. Again, this should be programmed in the simulator so that the crew, when they make an accident engine burn, can expect to see the attitude arrow needles vary as the vehicle goes through the pitch and yaw maneuvers.
We had no caution and warning lights associated with this burn at all. Both computers counted down, and the burn was really a very nominal burn. Instrumentation, we mentioned the decent quantity light. Other than that, any gauging or displays or caution and warnings were all nominal, nothing new or unexpected than the ones already mentioned. The reaction control system again was a very nominally operating system. The one thing that was very obvious to both of us, that when you put 100-pound thrusters on something with a hollow shell capacity of a LEM, we'll start with reaction control system again. The reaction control system performed in all respects nominally. A couple things worth mentioning is the fact that the 100-pound thrusters on the thin hollow shell of the LEM are not only noticeable, but they're extremely noisy and clangy. I guess it's more best descriptively described would be the fact that if you had put a wash tub on your head and someone banged it with a rubber mallet every time a thruster fired, that's the way the thrusters sounded. You could see the thrusters fire if you looked out the window with a long orange plume. Concerning control mode response, the pings pulse control mode with a light vehicle ascent stage only is about 3 or 4 times the authority you need for such things as Z-axis tracking in P20 and for P52 rendezvous. One pulse will send you in one direction and another pulse will reverse the direction, and no stop in between. So I'd say about 3 or 4 times the authority that you really need is available.
Right.
All the other phases of the system, translation control, all the subsystems associated with it, the pressurization, the gauging, the probes, warning, everything went as per activation and checkout control. Everything went as, from the operational point of view, as planned. One other exception is during the operation and checkout, during part of the cold fire pings checkout, we did not get the DSKY numbers we expected to see with the rotational hand controller. And these numbers were seen in real time by the ground, and we were given a go on a basis of the numbers that were read out, although they were not the numbers we had seen continually in the simulator. That takes us to the electrical power subsystem, and I can't speak too highly for this system of the LEM because the batteries were up to full charge when we got in. All the ascent descent checkouts performed well. We did all the we did most of the at least a third, until we started getting a lot of systems on the line, of the activation and checkout on the second day in low taps. We started out with the buses somewhere around 30 or 31 volts, and we got down to about 27 volts on the low taps, and switched to high taps, and we stayed well into the 29 to 30 volt region the whole flight. Ascent batteries were brought on as per checklist to warm it up. They took the load at staging without any problem at all. The monitor system for the ascent, descent, and pyros, ammeter, voltmeter, all worked well. All the status flags worked. Again, we had there was not one electrical or EPS subsystem malfunction or anomaly in the LEM that I can recall at all. explosive devices, all the pressurizations, deployments of landing gear, staging, every pyro function that was called for worked. We checked out each system individually by deploying the landing gear on one system and pressurizing the dips on another. Apparently got a clean separation of the ascent-descent stage as seen by photography and by the command module pilot. We had a good landing gear lock as seen again through photography and and inspected by and verified by the command module pilot. So we had good pyro systems. The lighting in the LEM was much better than I expected it to be operationally, because for the first time we had within the LEM natural light, which we never have in a simulator. We're in a simulator, we're in darkness all the time effectively, and the lighting is generally not very good. But a lot of our operation, 60% of the operation around the moon in the LEM is done in daylight, and the lighting is excellent. We had, at nighttime, we had adequate lighting. I have really no complaints about the lighting, the integral lighting or the flood lighting at all for nighttime operations. I saw absolutely no reflection, daytime or nighttime, in the window that bothered me at any time, as I expected, although there is some reflection in the camera during taking the pictures, but very little. And I was very much amazed that we did not get a great deal of reflection, but there was none at all noticeable. The exterior lighting, we had never really used our docking light. Our docking target was extremely visible to the command module pilot.
Yeah, well, how about the one in the CSM? Did you guys see that?
It was bright, but I think it was the attitude.
I didn't have it turned on. I forgot to turn it on. I had it all hooked up and I forgot to turn it on.
Okay, that was a daylight docking anyway. But the things to be aware of: once we turned the flashing light on the LEM, we never turned it off, because after the first P-52 I found out that there was no interference and no flashing light could be seen in the AOT. So for the benefit of the command module pilot's tracking, we left it on through all our P-52s. No problem with alignments. At nighttime, we could not even see it flash from through the window. We didn't know whether it was on except by verification from the command module pilot.
It was visible in excess of 300 miles. That's a great light.
Environmental control system. Oxygen supply, transducers, regulators, all were operating normally. We were in and out of helmets and gloves for most of the time, in helmets and gloves for the major burns, and for undocking and docking and for staging. The cabin held seal very well. As far as determining leak rates or anything else, we could not discern any leak rates. We did a normal switch over at staging to the ascent oxygen and water systems. Everything worked just as expected. Cabin atmosphere, other than the fact that when we got in there and started the whole day with a great deal of the insulation that we had blown in there from the command module hatch the previous day, this seemed to settle out pretty much. I guess maybe after our first descent engine burn, and we didn't see too much of it after that.
No, at first I was coughing and wheezing a little bit when I first got in there. And I'd take some water and wash it down, but no problem after that. I think it all did settle down pretty much after that first descent burn.
Okay, the cabin atmosphere circulation was adequate. We had one cabin fan on for a period of about 30 minutes. We both agreed that it didn't do anything for our comfort as far as cooling was concerned, so we decided that the noise level, although not extremely high and extremely objectionable, was there without producing any significant circulation or cooling, so we turned the fan back on and operated probably 90% of the LEM mission with both cabin fans off. While we're mentioning comfort, the LEM was comfortably acceptable. We didn't really do a great deal of moving around. We certainly were not cool or cold. Everything was set on a max cool condition configuration. It was adequate. I guess we weren't really hot and we weren't really cold. Weren't even really cool, but it was acceptable. The humidity apparently was very much under control.
Carbon dioxide?
We had noticed no carbon dioxide in the atmosphere that we could detect. The indicator was well below the caution area for carbon dioxide level. However, the ground said that they had detected an increase in carbon dioxide in the cabin, so we brought the canister back for analysis.
Yeah, they're saying it was up to 6.5 or so.
We never saw that in the cabin.
Right, they requested we bring the canister back, and the canister was brought back and is being analyzed.
My guess is that Mylar insulation and stuff
Probably.
got with it.
Probably reduced the flow or channelized.
I want to mention something. We talked about noise of the cabin fans. The majority of noise in the LEM, and the LEM is noisy. A great deal of noise comes externally from the thrusters. As LEM 3 reported, the repress valve, when you reposition a repress valve, it's a horrendous bang that can be heard all the way up in the command module. We anticipated this and tried to make ourselves aware and warn each other when we were going to move this valve, which was very infrequently. The noise level then without cabin fans in the LEM is produced wholly and solely by the glycol pumps. Glycol pump, we only ran one primary pump at a time. And the pump winds up and screams as if the bearings are going to go out any minute. It's not a extremely high-pitched scream, but it's a scream, a very loud, solid volume scream, such as that of a wheel that needs a great deal of oil, and that's the one noise producer in the LEM. For the record, the commander wore the fitted earplugs with the Snoopy helmet and significantly reduced his volume requirements on his audio panel. The LEM pilot did not wear the, although he took the earpieces in with him, did not wear the earpieces with the Snoopy helmet, had adequate comm, and was in a nominal 6 to 7 degree position on most volume controls, so he had capability of going higher. However, the volume was certainly adequate to hear everything that was going on.
Can I say something here about the command module? In that regard, the glycol pump in the command module, Tom could sleep by it, but man, it kept me awake. I don't know if that's a thing to gripe about, but it really bugged me.
I think there's a real tolerance in the individual's sleep habits where I can sleep by it.
I went over on the other side, I didn't have any trouble sleeping, just that little difference.
Right.
From the LMP's point of view, who slept on both sides, I've got to agree with John. I could sleep a lot better on the right-hand side, because when I went on the left-hand side to sleep, I felt that the pump was, well, and it was running right behind that bulkhead, and it was there all night long. When you sleep on the right-hand side of the command module, the pump noise gets lost in the environment. But when you're sleeping on the left-hand side, it's right there. We had no caution and warnings on the
Tom's probably deaf in that frequency range.
on any of the cabin atmosphere systems, and no further problems, no headaches. Once we got rid of most of the insulation from the hatch and got it settled down, there was little or no irritation. Water supply, when we first went in the LEM on the first evening before the rendezvous, the LEM water was found to have definite volumes of gas in it, and this gas was found to sustain itself throughout the whole rendezvous day, although it appeared that there were
Less
fewer
bubbles.
bubbles when we left the LEM than when we arrived. However, the gas was still in the water. The water tasted fine, but it was still gassy. Nothing further on the water because everything else worked great. The selection of ascent water at staging, we didn't use any of the waste tank fittings during that day. We didn't use any of the waste management systems. Takes us to the water glycol. When we first activated the water glycol, we did so without activating the primary evap flow, primary evap flow number 1. This was done as per checklist, as planned. However, the water glycol temperature at the point in the checklist where we did activate the evap flow was up around 80 or 90 degrees, and the glycol temperature light was on. Again, there was no problem. We'd known this would be the case, and the only thing I'm commenting on is it took about 10 or 15 minutes for the temperature to stabilize at its peak, even when we went into evap flow, and then about another 20 or 30 minutes to get down within the caution and warning range where the glycol temp light went out. So it's not an immediate process when you start pumping water through that water boiler that the temperature comes down. It's a slow thermal inertia process before you get down within the normal range of the glycol temperature. Beyond that, I guess I mentioned the pumps and their noise, but glycol, both primary pumps and the secondary pumps were all checked out. Pressures were nominal. The whole system was checked out as per activation and checkout list and flight plan. The auto transfer circuit worked during the checkout, was not used during flight. Really, again, here's another system that just performed as we had hoped it would. Suit circuit, circulation and flow was, I guess, what we expected it to be. Very low flow rate.
Low flow rate.
But we commented on the temperature and comfort already. The noise level certainly increased when you put your helmet on, as you had a lot of air flowing through the helmet. At one time, the LEM pilot attempted for a little bit more cooling of the face after he put his helmet on, went to the EV position on his suit diverter valves, and although it was cooler, the noise level was so high that I felt it was not worth trying to operate in that condition.
I tried that one time too, and you have a high noise level.
The rest of the information in 5.0 here, I think we pretty much covered.
The water accumulators worked as prescribed. The suit loop did not feel moist at all. So then we commented again in our analysis that we weren't warm, but we were just at the lower edge of the comfort level. Again, this has been remedied for LEM 5 and subsequent spacecraft.
The suit flow valve did not reposition at any time other than when we did it ourselves manually to connect or disconnect from the hoses. Cabin gas return valve worked. As far as 5.0, going right through the alphabet here, answering or making comments on all these questions, every one of these subsystems worked just as the activation and checkout checklist predicted it would work. And the results that we had were the results that are printed in that checklist to monitor. Telecommunications, the LEM MISFIN, LEM CSM, once we solved the anomaly, which was already talked about on VHF A simplex and eventually VHF A duplex ranging mode, once we solved that anomaly with the CSM after undocking, VHF communications were basically pretty good. There were times we lost contact, but I think that was probably because of antenna switching problems. But I believe the the level, the volume level, and the level of clarity was fairly good. John, you want to make any comments on VHF while we're talking about it?
Well, the VHF sounded loud and clear in the command module from the LEM, except doing 2 periods of time. Once when doing the just prior to phasing for about 10 or 15 minutes there while you're down low, and in your phasing attitude, and I think it was an antenna problem, and also prior to the insertion burn where the command module was pointed in the opposite direction from the lunar module, and I think that was an antenna problem too, and there was no way to get around it. The one objectionable thing about the comm was repeats, the repeating of your own voice transmissions, but that was probably on S-band due to some relay setup.
One other thing from the LEM point of view on the VHF, we operated in VHF ranging after the DOI burn throughout the completion of the rendezvous. There were times when VHF ranging was lost because of attitudes and burn constraints. Now, this VHF ranging on LEM 4 puts the 2 LEM pilots in a hot mic mode of operation, which was apparently not objectionable to the command module pilot. It also turned out that when we went to reacquire VHF ranging, as long as we did not say any words, even though we were on a hot mic operation and the command module was listening to the background noise of the LEM, this did not interfere with VHF lock-on. We got good VHF lock-on, I believe, every time we attempted to go to that mode. One other thing, every time we did go to reacquire VHF lock-on, we in the LEM could hear a low frequency buzz for a period of about 5 or 10 seconds. So we could determine this buzz either occurred at the beginning of lock-on, during lock-on, or at the end of it, but we could hear this buzz and knew that there was a lock-on procedure going on, and we didn't talk during that period.
Right. I think it occurred when you went, to the.
Let me say about how it performed after it got locked on. We had 2 or 3 cases where the thing was reading half range, and it was obvious because we couldn't have instantly closed to half range. And we had a couple of cases where at long ranges, or where it wasn't locked on because you guys were where we lost communication with each other, where it was reading zeros. And those are the obvious cases. And then close in, at close ranges like 0.07, 0.06, it would jump 0.07, 0.06, 0.05, back to 0.06, 0.07, 0.05. It was sort of shaky when you got close in, but out far, man, that thing was just riveted in there. It was just like it was on EMS.
And we correlated the VHF ranging with the raw rendezvous radar data through the computer, and the correlation was there, and it was usually within 60 to 120 feet.
It's really great stuff.
Okay, now the S-band. S-band clarity of voice transmissions coming and going on a high gain was excellent. On the Omnis it was good also, except that in operating in Omni mode to get the circuit margins that were required, we had to go to the down voice backup biomed switch on, which gave us hot S-band comm to the ground. And since we had been switching between high gain, because we want to maintain high gain anytime we could acquire it, and the Omni antennas, because we had to go to Omni every time we made any attitude excursion that might lose high gain track, to save the antenna from banging into stops, we went to Omni during P52s and during attitudes which would burn attitudes which would not allow us to maintain S-band track. We frequently went from the hot mic condition to the push to talk condition, and we did this so frequently that much of the time we weren't sure which we were in. All we were sure was that we had comm. But that mode, Omni mode, worked voice-wise probably too well.
Many times when we thought we were on intercommunications, it turned out that we were on a hot mic situation, and it wasn't obvious to the crew. You can't ascertain this.
Operation of the high gain antenna.
And again, let me bring out that we weren't briefed on this mode of operation until within the last week.
That's right.
Maybe the last week or the last 5
Last
days
week.
before flight. And we had not practiced like this at all in the simulator. And by then, all of our simulations were over. So
We
practiced.
didn't know until the last week of flight that this down voice backup mode would give us a hot mic S-band, and we did not know that the VHF ranging mode would give us a hot mic in VHF. Those two things, and they were known facts long before that last week of flight.
But it wasn't amplified as such in the AOH, and it wasn't
Simulated that way in a simulator.
it wasn't simulated that way in a simulator or with the total integrated simulations with the command module and mission control.
Remember, we tried rendezvous on Friday or Thursday, an integrated rendezvous where you guys ran in hot mic to see how it worked from insertion on in. Remember?
Yeah, it's the only one we did because we didn't know it until then.
We didn't know it, so we ran one, just a real fast one there. So we had one run just with John, but it wasn't the simulator wasn't set up. The operational mode in the simulator was not like the spacecraft.
I'm probably the greatest pre-flight skeptic of the S-band high gain antenna around, and I probably will at post-flight eat crow and be the greatest praiser of it, because the S-band antenna locked on when you got it anywhere within the reasonable angles. It locked on very readily. The signal strength came up slow but positive. You could manually tune it from low signal strength levels very easily to high signal strength levels. It would take auto track anywhere between about above 3.2, definitely 3.4 to 3.6. You could go from slew to auto track, and it would auto track itself right into a max signal strength of about 4.2 on a meter. Its operation was really fine. Two anomalies are, one of which we saw in the altitude chamber, is that when that S-band antenna moves, it sounds like the bearings are
Grinding.
four-cornered bearings instead of round. It just grinds and grinds and grinds. We saw this in the altitude chamber. I was a little bit surprised because subsequent tests in subsequent altitude runs on LEM 4, this was examined and found to be, the noise that we heard in the altitude chamber and in flight was found to be non-existent. They said there would be no noise. There was a lot of noise.
In fact, you could hear it during the initial activation and checkout in the command module. You could hear it grinding away, and also the vibrations would shake the total stack.
That's right. Set up the natural resonance frequency of the total stack.
Prior to any anticipated high gain loss, so that the S-band antenna would not track into the stops, which meant prior to LOS, prior to P-52s, and prior to any special attitudes we were going to, we had to take the S-band antenna, slew it to a pitch of 90 and a yaw 0, which was basically a neutral position. Let me finish this. Basically a neutral position, and then go to the omni condition for the remainder of COM during that period of the flight. And there were a time or two when we forgot to do this, and what happened was, yes, it did bang into the stops, and as soon as it banged into the stops, it blew the on panel 16 the S-band antenna circuit breaker, and of course you immediately lost any S-band movement with the high gain, and you lost the meter or the capability to slew it. But this happened 2 and maybe 3 times. That circuit breaker was reset, you immediately regained slew control, and the antenna worked nominally the rest of the time. So it apparently did not hurt it those couple times, but it did pop the circuit breaker every time it hit the gimbal stops. The final item on the S-band is that on the night before rendezvous, we went through our S-band DTOs, and we got excellent results. In most cases, these results are obviously more readily attainable on the basis of what Ms. Thin was able to determine about their TM capabilities as well as voice. We checked out Vox, PTT, and ICS PTT during these DTOs, and they all worked. The anomalies of the comm system were such that in some areas where signal strength was expected to be higher, it was not as good, and in some areas where they expected to get little or no, such as the FM modes, the signal strength and the voice were excellent. There's obvious, I really believe there are some modes we could have been operating in flight, on this flight, some omni antenna modes that we probably could have been operating in that would have eliminated, gave us good enough comm that would have eliminated the hot S-band mic to the ground, but that's water over the dam at this point. One other item in comm is on the night during the DTOs was being checked out, we initially did not get voice transmission from the spacecraft to the ground. That is because the down voice backup switch is a 3-position switch. It particularly in this spacecraft happened to be a very stiff switch, and when the LEM pilot thought it was in a down voice backup, although it physically positions itself in that direction, it still goes one step further to the down voice backup position, and it actually was an off during the first segment of the DTO test procedures.
This is the end of Reel 5, and it is complete through item 15, which is Lunar Module Systems Operation.
Pigs live there.
Sarah.